Hello, my name is Josh Obrecht, and I'm a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Merge Stream Reach with Water Bodies tool. This is the fourth tool in the Stream Network and Catchments section of the ACPF Toolbox. This is an optional, though highly recommended tool that merges your stream reach with any water bodies you have in your watershed. It allows water body features, such as wide rivers or lakes, to be merged with your stream reach, giving you two stream reach coverages and a polygon output for your water bodies. You have the option to include these water body boundaries in later tools, such as the Riparian Assessment Suite. Here's an example of both a wide river and a lake feature. If you do not already have lake or wide river features, you may be able to get them from other sources. Maybe your DNR has already digitized them. Maybe there's break lines from the LiDAR flight, or they can be obtained from the National Hydrologic Dataset. If not, you'll just need to digitize them yourself. A key thing to note is that you need to make sure that your flow paths from your stream reach stay inside these water boundaries. Previously, tools like distance to stream or height above channel would give false results when run on watersheds with lakes or wide rivers. The stream center line was usually within the middle of these features, as you can see here along this wider river. This poorly represents where shore and bank lines are, which is what the previously mentioned tools are dependent on. This tool, merging the stream reach with water bodies, fixes that issue by using the boundary of lakes and wide river features as bank lines. For example, we have a lake feature and we also have a wide river feature. Using these layers, our height above channel results will now respect these features. When we did not include lakes or wide rivers in our assessment, the height above channel output would look like this, where you can see this lake is being classified as less than 1 to 5 meters above the channel. There are also in-channel portions that are also classified as less than 1 to 5 meters above the channel, which is wrong, and this is a misrepresentation. However, when we include these areas will now be clipped out, and the change in these areas along the lake and along the wide river are now better represented, and the in-channel and in-water body portions are accounted for properly. Back in ArcGIS Pro, I have added two layers, a wide river layer and a lakes layer. Both of these were obtained for this watershed from a set of break lines used in the LiDAR acquisition to hydroflatten the DEM. We will now go over how the water bodies need to be edited to contain the stream reach. Both of our lakes and our wide rivers are shown in dark blue. When editing our water bodies to include the stream reach, we are going to be looking for areas where the stream reach line runs either really close to the edge of the water body. Most times it will go in and out of the water body. However, it may not be able to be seen when you are zoomed out. Here we have our wide river. We have a nice bend in it. We can see our stream reach is running right along the edge. If we zoom in, we can see our stream reach actually does flow out and then back in a few spots around our wide river. To edit the wide river, we'll turn on the edit toolbar at the top of our ArcGIS Pro window. Click select. Click the wide river. We will click on the reshape button in the tools section of the edit toolbar. And what you want to do is just get your polygon out just enough to include the stream reach. So we will find a position on our polygon, click once to start the point, and then just go out a little bit, reshaping the polygon. Double clicking to end the line until the stream reach is included within the polygon. You will continue to do this throughout the edges of the wide river. One other thing that needs to be done with wide rivers occurs at the exit, and if your watershed is not a headwaters watershed, the entries. For the most success in your results, you will want to have your stream reach create a little tail in relation to your wide river. I have zoomed in on our exit pour point. Looking at the stream reach and wide river, the stream reach line sticks out from the wide river to create the tail that I mentioned. You may need to trim off a little bit of your river polygon to create this. Once the wide rivers are done, you will do the same with lakes. But there is one thing that needs to be done first with lakes. We have found inconsistent results in future tools where small ponds are included in the merge process. It is recommended to remove any lake polygon with a perimeter less than 500 meters to represent realistic riparian corridor management. Once these features have been removed, you will want to edit your lakes in the same fashion you edited your wide rivers. Once our lakes and wide rivers have been edited to incorporate our stream reach, we can run the tool. We will open the catalog window, if it isn't already open, by clicking the catalog tab on the right side of our window. We'll expand toolboxes, the ACPF toolbox, and the develop stream and network catchments drawer. We'll double click on the fourth tool, merge stream reach with water bodies, to open it. We have 4 inputs, the first being our stream reach. In the drop down for input stream reach, we will select our stream reach. The second input will automatically populate with the flow accumulation raster from the ACPF geodatabase. The third and fourth inputs are our lake polygons and our wide river polygons. We'll choose our corresponding layers in the drop downs. There will be some instances where you only need to choose one of them, if you have only lakes or only wide rivers. The first output has been automatically populated. Note that the output's name is StreamReach WB, and then we can optionally make a water bodies feature class. This is going to combine our lakes and wide rivers into a single polygon feature class. If you only have one, you do not need to create this output, but because we have both, we are going to create it. We will click on the folder next to the input box for output water bodies feature class. We will click on folders on the left side of our window, double click ACPF data, double click our geodatabase, and then we will name our file water bodies and then the HUC12 number. We will enter this into the name box. We will then click Save on the window. Once we have all of our inputs and outputs set, we will click on Run at the bottom of the window. The tool has finished running. Our 2 output layers have been added to the map, StreamReach WB and water bodies. Let's zoom in to get an idea of what the tool did. We have our lakes in orange and our wide river in dark blue. Previously, the stream reach, shown in light blue, flowed within the wide river. Now the stream reach includes the bank lines of the wide river and the shoreline of the lakes. Everything is now inclusive. Our water bodies feature class also has combined our wide rivers with our lake features. Right-click on our StreamReach WB layer and choose Attribute Table from the menu. All the information that was previously carried with the StreamReach feature class is gone, except for the field link no, our identifier for each of these segments. We also have our water body type. If we sort by link no ascending, everything that has been added because of the wide rivers or shorelines from the lakes will start after the largest link no for streams. In the water body type attribute, the streams are the ones that previously existed. Wide rivers are associated with the wide rivers, and shorelines are associated with lakes or ponds. Going forward, if you have a tool that asks for stream reach as an input, and it gives you the option of using stream reach with water bodies or without, You'll have to make that choice. If you choose to use your stream reach with water bodies, it will ask you to include your water bodies polygon. If you decided not to create this because you only have lakes or a wide river, then you would just use either of those as the water body's input. To recap, we discussed why using wide river and lakes polygons is beneficial. We then ran the Merge Stream Reach with Water Bodies tool. The next video will begin to create results by running the first field characterization tool by field slope statistics.